Hello, this is video 3, and in this video we're going to go over the rules for naming alkyl halides and ethers. Alkyl halides is one family of organic compounds, which are also called the haloalkanes. This name reminds us how they are being named. The functional group is a carbon-halogen bond, and the substituents, depending on the halogen, can be fluoro, bromo, chloro, and iodo. Actually, the rules are quite similar. You find the longest chain and you assign numbers to give the lowest numbers possible to the substituents. So that this particular compound is 3-fluoropentane, because actually either end would give you carbon 3 as having the F substituent, and iodocyclohexane. Now here are some examples of slightly more complex haloalkanes, and you can see that there are other substituents other than the halogens as well. But basically the same rules apply. You find the longest carbon chain, and then you give to the substituents the lowest set of numbers possible. In this particular example, whether you name from the left or the right, you'll see that you end up with 2, 3 as the substituents. However, we pick this name as giving 2 to the bromo because B comes for C, and we assign, when both numbers are even the same, that the one that comes earlier in the alphabet gets the lower number. So you may want to pause at this stage to have a look at the other examples to make sure that you understand how the rule is applied. Another functional group is ether. This is the functional group that contains a carbon-oxygen-carbon bond. And depending on what is actually on the carbons, there could be 2 similar alkyl groups, and we would call this a symmetrical ether, or they could be different alkyl groups, and we would call this an unsymmetrical ether. How do we name ethers? Well, if they're unsymmetrical, then the shorter group is named as an alkoxy substituent. So we learned about the alkyl group already, but if there is an oxygen, we call this the alkoxy group. So a 1-carbon alkyl group is methyl, a 1-carbon having another oxygen is a methoxy group. Then it's an ethyl group as an alkyl group, but the alkoxy group is ethoxy. Then you use this as a substituent on the longest parent carbon chain. Let's look at some examples. So for this first molecule, we see that on one side there's 1 carbon, but on this side there are 3 carbons. So obviously 3 is more than 1. So it's going to be named as a derivative of propane. And then this part here is the alkoxy group. So that is why this is 1-methoxypropane. In the second example, the longer carbon chain has 4 carbons. Therefore, this is the shorter one, and it is named as an alkoxy group. So in this case, 1, 2, 3, 4 is the lowest numbers possible to the substituent, and we have this molecule named as 2-methoxybutane. For this particular ether, notice that this here is the fragment, the R group, that has more carbons. So we name this as a derivative of the longest carbon chain, and it has 1, 2, 3, 4, 5. So it is a derivative of pentane. But it's more than that because there's 2, 3, that is 2 methyl substituents off of it, so that makes it a 2,3-dimethylpentane. And finally, having this particular substituent is a 1-butoxy, because it's a 4-carbon alkoxy group, 1-butoxy 2,3-dimethylpentane. Now, just as before, if they're the same substituents, we can use the prefixes that indicate them. So this particular molecule here is a 1,5-dimethoxypentane molecule. This is the end of video 3. You may want to take some time to pause and review before going on to video 4, which is on alkenes and alkynes.